capacity for joint object recognition and pose estimation using nonlinear generative model. So as you can see from the name that we are proposing nonlinear generative model to answer this question. So what is the object in this image and what's the viewpoint? And for doing that, we are using actually manifold modeling for objective view manifolds. So why we are using manifolds? Because as you can see from this slide, images, objects, I mean the appearance of objects in images is subjected to so many variations for style, category, viewpoint, illumination, a lot of variations. So to have actually robust model that can capture these variations in the feature space, you have to put so much care. And actually, despite the availability of huge datasets, the kind of or the factor of variations that you may be interested on is not encoded correctly in the dataset. That's why you may need to have some kind of manifold analysis for the problem. So actually, this is how we imagine the feature space. This is actually the image feature space, and how this is what we imagine that image feature space. This actually that image feature space is actually set of bunch of image objective view manifolds, and the objective manifold is the manifold that connects the images of the same object from different viewpoints. Okay, so the question is how can we model this manifold and how we can solve the two problems, object recognition and pose estimation, simultaneously. So this is actually the proposed framework. So it has two phases. The first one is manifold parameterization, and the second one is embedding in a low-dimensional latent space. So what's the manifold parameterization? I want to parameterize the objective view manifold. So this is actually the mathematics behind it. We have actually closed form for that. It is based on the work that's proposed in 1990. To know more detail about that, please come see me. And the second phase is little dimensional embedding. And here actually we used KPLS, kernel partial least squares. It is actually nonlinear supervised dimensional reduction technique. Why we use KPLS? Especially because actually it minimizes the reconstruction error. We need that for the generative model. It is supervised. It increases the robustness of the classification, and also it is nonlinear, which means that it will encode the complex relationship of the points in the parameterization space. And what's the parameterization space? That's actually the space that's generated from the manifold parameterization. So actually, this is the generative model that we have. At the very end, we have a style space that encodes the category, and we have the viewpoint space. And the generative model here actually compose point in the style space and point in the view space to generate image in the feature space. Okay. Using generative model, we solve this objective function, which basically minimizes distance between test image and predicted image. So the objective here, or the solution, will be a point in a style space, which is the category, and point in the view space that actually best match with the test image. And this actually, for doing that, we used sampling and gradient-based technique. For the experimental result, we deal with data sets which called multi-view data sets. We have 3 public available data sets. We experiment on all of them. In 2 of them, we get the state-of-the-art result. However, in this one, we get the state-of-the-art result for the pose estimation, but not for the categorization. Why that? Please come visit me on the poster. And for conclusion and for future work, please come visit me in the session. Thank you.